Hello and welcome to this lecture on the C preprocessor. What is a preprocessor? A preprocessor is a program that runs prior to compilation of a program that will replace text inside of our C files. So a preprocessor typically takes commands that use a hashtag to indicate text replacement or specific functionality to run against that line of text. We can use GCC in our files to pass in the -E flag to produce output on our terminal to show us exactly how these things work. So here's an example of how a preprocessor defined macro works. Now you'll see on our left is our source code. We have our function, our typical main function, defining two variables with two defined statements at the top, capital X and capital Y. And you'll see that there's two numbers next to each of these capital X and capital Y's. So just looking at the program, you'll see that we declare two actual variables and we assign them to these capital values up that were defined above. Now on the output, if we use GCC with the -E flag, and this is redirecting the output to a particular file, when we use that flag and redirect it and then read the file by using the cat command, it will dump all of this text out. And you'll see that these #define statements are no longer inside of our actual code here, and that they were indeed replaced with the value 10 and 5. So go ahead and pause the video and give this a shot with our Hello World program. You should see a bunch of text being dumped out from the #include or #include statement from the preprocessor. The include directive is actually going to take the content of the file that is within the greater than less than symbols and dump it out into the top of your file. Okay, great. Now that we've gone ahead and tried that, here is another example of how to use the define directive, but creating a directive that is actually works kind of like a function. So if you look at our define here, we define something called multiply. We have an open parenthesis and then we list parameters or inputs here, and we have X and Y. And then our actual definition, it's always safe to wrap these inside of parentheses so that way it groups things properly. Remember that it's just a text replacement and that it's difficult to actually gauge when you can basically end up with tokens that do not compile correctly. Tokens being characters that do not compile correctly in a C compiler. So we add these parentheses here for order of operations and just to have a nice clean piece of code. So we have this define in our code. We actually put int x equals multiply 2, 5. And you can see in our output when we use GCC-E main.c, we just dump it out to the terminal this time instead of redirecting it to a file. And you'll see that our value here, first of all, we do not have a define statement. And next you can see that we actually replaced our values with this second portion of the define macro. So there are actually a ton of different preprocessor directives. All of these might be using in this course. Some of them are not really relevant at this particular stage of your programming career, but it's good to get slightly familiar with some of these things and just kind of understand what each of them can do. So here's the list. If you're interested, you can read more about it online, or you can purchase a reference manual for C that actually goes into detail about each of these. So let's go ahead and let's mess around with the preprocessor and spend some time compiling our programs using this -E flag. All right, so let's go ahead and dig into what a preprocessor does. Now, go ahead and launch your Visual Studio Code instance or whatever text editor you're using for this course, and you know how to do this. We've set this up a few times, so we're not going to go through it in every video. So I launched it. I am actually inside of the directory already for where our typical code is. I wiped it out. If we print the working directory, we are inside the C dev folder. So just because we were practicing how to use the command line, let's go ahead and make a file by using touch. And we can say main.c. And now we can type in code main.c to load that file into our code editor. Let's go ahead and minimize that terminal. Now let's go ahead and just do our basic implementation of our program without any includes or using any particular directives. So we're just going to go ahead and have this very bare minimum program. And let's go ahead and compile. So let's clear our screen. Then we're going to go ahead and type gcc main.c. And you can see that we have a a.out file. And if we list, it's right here. So that's great. Cool. We have a program compiling. Now what else can we do? Well, let's just mess around with this pound define directive. So up here, let's make a pound define. And I don't know, let's call it a test. And then test is going to be, let's say, I don't know, 100. Let's make an integer, let's name it x, and let's assign it to test. Now we'll save our file, and let's go ahead and open up our terminal. Type gcc, capital E this time, and our file name. And we can redirect the output, but let's just have it dump out to our terminal first. And you can see that there's no longer this pound define, and it was actually replaced here, test, 100, 100. So it does a text variable replacement, something that we saw in the slides. But I just wanted to show you in here before we get into like a little bit more complicated implementations. So let's go ahead and let's do this. Let's redirect our output to a file, so that way we understand how that works. So you can see when I just typed this command, it just dumped it out to our terminal. Now what I can do is I can do something called a redirection operator inside, and this is specific just to Linux. How to do this? We're going to take that output that was put on our terminal, also known as standard out, and we're going to redirect that to a different file, and we'll call that file temp.txt. So let's clear our screen. We can hit the up arrow key to run the last command, and we can make the greater than symbol and then type our file name. So we can say, let's just do test.txt. And you can see that a new file was created. We can double click or open it however you'd like, and look, it has our text. You notice that the text was not actually echoed to the terminal here. It was just dumped into this file. So you can see the results. And the reason why we're going to do that is because we're actually going to see what happens when we do this with our Hello World program. So let's go ahead and write our Hello World program. We need to include io.h. And now from here, what we're going to do is we're going to call printf hello. Let's make a capital H. It's always nice. Exclamation point /n. Don't forget to terminate our line, we use a semicolon. So now let's go ahead and rerun that last command, dump it to test.txt, go ahead and open that, and wow, look at all this stuff that was just dumped out. Our little file, so we have a seven line file, has now been blown up into a almost 860 line file. So this is huge. Now, what is going on here? I believe in the other lectures I told you that this just takes this file and replaces the text inside of it. So let's go ahead and do that, and with our own files. So just so you know that we'll see this in a second, but our include, when we have it inside of the less than and greater than symbols, we are essentially saying that there's a standard location, an include, it's typically called an include location, for us to seek for this file. Now, when you're in the same directory, you cannot use these if your file that you're looking for is in that directory. I know that sounds a little confusing, so let's go ahead and just test it out. Usually, instead of doing these less than and greater symbols, you'll typically put them inside of quotes. And that just tells the compiler to look for it in that particular location, or the preprocessors to look for it in a location in general. So I know this is a little confusing. First things first, let's clean up our directory here. Let's go ahead and remove our a.out file. Let's remove our test.txt file and clear our screen. We can see we only have this file remaining, our main.c file. Let's go ahead and remove this include statement at the top. And we're going to go ahead and remove this printf. Okay, great. So now let's go back to our terminal and we're going to create another file. We're going to say touch.test.c. Okay, so now what we're going to do is we're going to type code test to open it in our text editor, and we can actually move it over and split the windows so we can see what's going on here. Now what I'm going to do is I'm going to make a function, or a pound define function inside of this file, and I'm going to name it, let's say, add, and we're going to have x comma y, and that's going to be in parentheses x plus y, and that's all we're going to do inside of this file. So what I'm going to do inside of our main file is I'm going to include this C file. Now typically people will say not to include C files, but we're just figuring out how things work. Whether it's a C file or a .h file, it doesn't really matter. It's just a text replacement tool. If you recall, we have normally when we use printf, we have a stdio.h, and this file has a C. We can rename this to a H file or a C file. It really doesn't matter. It's just there's particular standards that people like to follow, and we don't necessarily have to follow those standards. We can do whatever we would like. So therefore, we're just going to go ahead and make an include for our C file. So we can say something like test.c. We can save this file, make sure this file's saved. And now in here, what we're going to do is we're going to say int z is equal to add, and let's say 5, 5. So we're going to add, let's make it a little bit more interesting, 5 and 6. So let's go ahead and compile this program. So we're not going to use the -E directive. We're just going to compile it and run it and see what happens. Nothing. It actually produced an out file, a.out file, and you can see that it can run without crashing, so that's great. Now what we want to do is let's use our new flag that we found out about, which is -e, and we're going to pass in our main.c file. So what you can see now is that what was replaced was this file was included, but this function here was actually it's not a function, it's a macro function, or whatever you'd like to call it. It actually replaced this here. So all we did was simply copy this code into here and then place it inside of this particular file. So you can see it's a text for text replacement. We can also include std.io.h and give us a little bit of output here. So we can say printf z %d. Let's do a new line and let's print out z. So what we're going to do, let's go ahead and just compile the program and run the program, and we can see that it's 11, which is correct. When 5 plus 6 is 11. So let's go ahead and now dump out our output from the preprocessor to a file. -e main.c. So let's go ahead and test.txt, and let's look at this guy. We'll close our test. We'll close this terminal and look at all this stuff. Let's go ahead and scroll all the way down to the bottom here. Go a little bit up, and you'll see again that all it did was just replace this text, and all of this junk up here is from the stdio.h header. Then you can see that it was included here. And all of these other includes are usually defined inside of this stdio.h. So that's why all of this stuff is in here, and then you can see it just gets crazier and crazier and crazier. Anyways, I just wanted to make sure that you knew exactly what was going on. I know a lot of the times these include statements confuse people. I know it certainly did when I was first starting out. So I just wanted to shed some light into actually what was going on there, because usually people gloss over it. Now these functions are not the actual body of, you'll notice that all it says is stuff like, let's search for something like printf, right? So you can see that there's a bunch of printfs. Here's the actual function definition for printf, but there is no actual body. And the reason for that is because the actual body of a program is defined in something, another piece of code, and we link against that piece of code. But in C, we need a predefinition to tell us how to use the function. So think of it as like something like a table of contents. You need a table of contents to tell you where to go, and then when you go to that particular place, it will actually show you the definition of that particular item that you're looking for. So same thing, you need to link against either something called the static library or a dynamic library, something along these lines. And that is a topic of linkers and loaders, and we'll get into that probably later on in the course. I just wanted to expose you to exactly what the preprocessor does on a very basic level, and you can see things can get kind of crazy. It's a very powerful tool and something that you should familiarize yourself with. Great, thanks for watching. Hope to see you in the next lecture.